Okay, so the lesson has started. We will continue off from where we left off in the class, right? And what we're going to do is look at how many floors we have for the development, okay? So if we look through, we'll look just up here to see how many floors there are. Scroll straight in. We can see that we've got the 17 floors all the way up, yeah? And that's the parapet level for the parapet walls. I'm assuming it's got a flat roof. This elevation happens to be the elevation on the high street. If we scroll in, we could probably see it better. And you could tell that it's probably got like a timber wood cladding type system on this elevation. If you look at the detail properly, it is. And on this elevation, you've got 8 floors. So what we're going to do is look at the site boundary as well. So it will give us an idea of what locations and how we also sequence it based on the overall site plan. So I'll go back to the site plan and we look at the proposed site plan, site setup. Okay, I think it was this one. Hopefully it comes through. Okay, fantastic. So this is the site setup. If we scroll into this, we'll see all the... 1 second. Let's close that. Alright, so let's scroll further in. And as you can see, we've got block A just over here. We've got block B here, block C here, block D, and block E here. So if we go back to this drawing, what we can ascertain is what location or what elevation this faces. Okay, so from the drawings we can see it's the high street elevation. We go back to the site plan and we see the high street elevation. So the assumption is that whichever one of these blocks it is, I'm assuming it's probably block A that's got the 17 floors. So let's try and ascertain exactly which one of the blocks it is so we can divide up the WBS packages to the number of floors there are. So you have block A, block B, block C, block D. Let's see if they've given us an annotated description of what block it is that we're actually looking at. Okay, because as you can tell there are multiple floors on there. Okay, what block are we having a look at? Hopefully it's been... Okay, so it's a brick cladding system. Okay, and this is... Okay, so it's got reconstructed stone rain screen as well, an aluminium rain screen. So it's a combination of 3 different systems, inclusive of an opaque glazing system. Alright, so if we scroll into the... I just need to ascertain what blocks we're looking at. And it says, yes, block A, so it's the core for block A. So this is block A, right? Let's open up block B, block C, block D, so we know exactly what it is. Let's go to the elevations. We've got block A, high street elevation. Let's look at block B and D. Have we got a block C? We can't actually see block C, can we? Okay, so let's see high street elevation as well for this. Alright. Okay, so we've got blocks B and D. We can see how many floors have they got. If you look at it, it's got 7 floors. 8 floors, okay? 8 floors for block B and D. Alright, so these key bits of information would obviously ideally help us. Pavilion elevations, we have a look at block E. And we can ascertain that block E has also got a cladding system, which on further investigation, looking through on the legend, it will probably give us an idea. So it's a zinc interlocking panel system facing brick, and also anodized aluminium panel, so that probably be AL203, but anodized basically means there's a cathode and an anode. So within the wall system there'd be an anode which would prevent obviously corrosion from occurring. So the anode and the cathode system, which will be installed on the probably the inside of the system, is what will actually rust as opposed to the cathode. Okay, so it probably have a long lifespan of however long it's obviously allowed for rust and corrosion, etc., before it needs to be changed. Okay, so it's like a battery system basically. All right, so we've ascertained we've got what, 4 floors on this elevation here for B and D. So we've got a variation of different number of floors. Right, so we go back to our program that we were developing on Saturday. Oh, somebody is trying to get in, so well, they're late. I'm sorry they can't get in. It's disturbing the class. You should have been quick. Alright, next time when you've sent the password, you should get in as quick as possible. So can somebody put in the group to ask that person to stop trying to get in, because it's disturbing the recording. Alright, so these were the WBSs that I gave you the last time. So now that we've ascertained, obviously, in the construction phase, we'll open that up, look at the enabling works, groundwork, superstructure, the frame. Obviously, we're going to need to put, in the frame bit, we're going to need to put all of the floors. So we know we've got a core for block A and block B and C, judging from the drawings. Okay, so for the site plan, you could see that. If you look at the drawings for the site plan, that's annotated, you'll see that there. Let me push this down and we go to it. Okay, so here you can see this is the core here. Yeah, this is the core where the lift overruns will be built and erected. You've got another core here in block B, and then you've got another core for block C as well. Okay, so 3 cores, and I believe we've also got a core for blocks E as well. So we go back to our program and we've got the RC frame. So let's give the activities for your RC frame. Usually what would it be? The first would be to put the uprights, which is the walls and columns. Yeah, okay, then has somebody posted that in the group to tell whoever it is that's trying to get in to please just stop trying. We lay the steel rebar. Okay, so this is the sequence here. So walls, columns first, and then the decking, lay steel, pour concrete. Now what should you do? Obviously you're pouring concrete. You should have a quality control, quality check, or quality assurance check for this particular activity. So you let the concrete cure. Okay, so cure concrete, and then you do a QA check. Alright, so we've got this sequence, and this sequence is going to follow up for RC frame, but for which block. So that then tells you that you go and create your WBSs for all of the blocks. So we've got the RC frame here, so we'll do it for A, B, C, D, E. Okay, so you create that, create the second, create the third. A, B, C, D, we've got one more. Okay, so there we go. We've got the frame for, that's block A. Let's take that. And that's copied over there. Just do that. Alright, so that's all created there. You've got your core here, which realistically should go just under the RC frame. So I'll put that back down there and move it to the side, because all of the buildings have cores. So you ideally will erect the core for block A first, okay? Because that's the lifts that you're erecting. So you add that, and you've got 4 of them. Or 5, should I say, because there are 5 blocks. Okay, so do the exact same thing, just copy them. Alright, so that's completed now. So we go back to the actual activity window here, and then what you want to do is, for all of these activities here, these activities represent the frame, the actual structure itself. Okay, so what we do at this point is we copy these activities, right? They won't go in the core, because the core is for the lift. So where they would go would be the actual frame itself, and this is where we would paste them all. Guys, can you not move your mouses, please, or your buttons, just so it doesn't, you know, keep popping up with the arrow? The reason why it's so slow is because it's having to do so much, because quite a few people are logged in, but it will sort itself out. It's taking a hell of a long time to sort out. As soon as it's copied one, you kind of get the idea. You know, I don't want it to, delay our whole process of what it is we're trying to do. Okay, so that's that done. All right, so for the core, what we will do is basically create an activity in each of these columns here, and we'll just let those activities represent however tall the elevations are. Okay, so just put that in there. So ground to lift overruns and upstands is what we will do. Okay. Okay, so we say the block A. So let's go. And you do the same for block B based on the number of floors. Let's just assume it's however much, just so we don't. Ideally, we haven't looked at what block B's height was. I think we said block B was about 8 floors. Yeah, it was 8 floors. So we come back here and just obviously highlight that and paste, and we put it at the 8th. Okay. And so on and so forth. Okay, so literally that's the sequence of how it would go all the way up. I'm assuming that block E was, I think, 4 floors. If we look at block E, it looks to me like it was 4 floors. Yep, I'm correct. 5 floors actually. Okay, because you've got the lift overruns here, and that's the parapet wall to the top of that elevation. Okay, so this is 4 floors for block E, as you could tell. So we'll put it up in there. Put the 4th. Alright, so that's that sorted. So what we will do now with these activities, obviously I don't want it to delay us any further, but block A, obviously this is the sequence for 1 floor. You'll repeat this system for however many, from 1st floor, 2nd floor, 3rd floor, 4th floor, 5th floor, 6th floor, 7th floor, all the way up to 17 under this WBS, because it's got 17 floors for block A and 8 floors for block B. Block C and D, we haven't ascertained how many floors they are until we look at the elevations for block C and D. Block D and, well, D and B I think are located on the same path. So if we have a look at it, we'll be able to ascertain that. Okay, so let's see. Alright, so this is block E. Alright, that's fine. And we've got blocks A, block B and D. So B and D are identical to each other from what I can see. This is blocks B and D. So let's, okay, so they're probably the same. But anyway, you'll get the gist of what it is that we're trying to do. So B and D, if we look at the end elevations, courtyard elevations from within the building, yeah, we ascertain how many, and yes, they are the same because they're superimposing each other and they're opposite each other as well. So we know that they will have 8 floors as well. Okay, so that's fine. So we know obviously you do this, the same thing all the way up to the 8th floor You do the frame for this all the way up to the 8th floor or to the roof. You do it up to the roof because the frame will go up to the roof, right? We're assuming we've got flat roofs on all of these and parapet walls, okay? Once you've done that, you've completed your frame. Now, with the roofing, you will lay, well, the roof will be concrete, but you'll lay a damp proof course on top of that, right? And the activities for that had been previously done in a previous lesson. If you come up to where the roofing activities are, you felt it, rain screen on top of it. So weatherproofing, basically the roof works, the roof trusses, the soffits, fascia boards, all of the rainwater goods. Okay, so RWP, rainwater pipes, the guttering, etc. Right, you do all of those, and then you, if the roof has obviously got a pitched roof, a flat roof, etc., and it requires any cladding, you'd clad that. But prior to the cladding of the roof, you would have fixed the roof trusses or roof framing, and then you fix the roof cladding. If it's a flat roof, you install the flat roof, and then you put a hot melt over it, and then you put a layer of insulation over it, and then if it's required, obviously, I'm assuming it's concrete. So with concrete, you're probably just gonna obviously make good the concrete. I don't see any reasoning behind trying to get any damp proof or waterproofing on top of a concrete roof. Okay, because the frame will go right up to the roof anyways. But if you did have a roofing system, it would be this sequence here. So the roofing works would be roof trusses or frame, then the soffits, the fascia boards, then obviously you install the roof cladding on top of that, and then you put the felt membrane on top of that as well, and then at that point the building's watertight. Okay, so from the drawings we saw that we had 3 different types of systems on this building. We had the rain screen cladding, we had aluminium cladding, and we also have timber. Okay, we could see that. We also have brickwork as well. So the sequence for that would be, first of all, you get the SFS framing up, and then after the SFS framing, it could either be METSEC, then the SFS framing, then the CP boards, and then the EPDM. So basically the EPDM will go round the windows that you have hung, okay? And that obviously is to weatherproof the windows when you hang them, okay? So after weatherproofing the windows, the next sequence will be what? It'll be the brickwork, and then after the brickwork is the rain screen cladding system, okay? And after the rain screen cladding systems, you can then obviously fix your doors, windows, etc. So at that point you could say, obviously, as soon as the windows go on, the building's partially watertight. Well, it was watertight from when it got to the roof, but you know, once you've hung the windows, the building is actually considered as watertight. So you can start your internals, or you can start your rough plumbing, etc. Rough plumbing, MEP, rough mechanical, electrical, and plumbing. Okay, so this is all of the stuff that will go into the blockwork, right? Right the way up to 17 floors. So I close this down, and this is just for reference purposes. It was built already from one of the previous lessons that I had with you guys. So what we do here, we've got the roofing, which as discussed, we have, hold on, we have a concrete roof. Okay, so guys, remember we've got a concrete roof, but it's a flat roof system as well, with a parapet wall to the side. So what we would say is, at this point, we'll do what? For the frame, we'll erect the parapet walls. And then probably hot felt. Okay, so that's that. Now, the envelope system that we're going to have on this building, as I've just described to you guys, we're going to have a series of different systems. Judging from the drawings, as we saw earlier, if we scroll into the drawings, you could see the configuration of all of the exterior envelope that goes around the building. Okay, so if we scroll in further, you'll see all the different systems required. Alright, so you see the bricks, opaque glazing in the internal lining, which obviously is double glazing, that's what that means. And then all of the grey areas will be the anodized aluminium panels, okay? And then you have aluminium rain screen panel as well. So if we scroll to the drawings, we can clearly see that. Okay, so just follow through. As you can tell, that's how you read drawings. You look at the annotations, you come to the drawings, and you look at the legends. Okay, so you can see that there, opaque glazing, internal lining, walls, internal lining, that's the glazing, the windows. Okay, and then at this area here, you can see exactly what it is. When you come, scroll up here, you know it's brick. Okay, you scroll down again further, and yeah, so majority of this elevation is brickwork. Okay, so we get down here, we scroll back up, you look at what it is. As you can see up there, it's the louvers. So it's got a louver system, okay, on the ground floor, which literally is like a system arrangement. When they say louvers, it's not the actual louvers like you think it is. It's not. It's basically a rain screen cladding system. It's the arrangement that they call the louver system, okay, which is, it goes over each other, like basically pointing downwards, and then just slightly underneath the top tile, you'd have another tile just underneath it. It drips whatever moisture, water, etc. that pours over onto the other panel, which drips it further down until, you know, it hits the soil or concrete or pavement, wherever it is that it bleeds water to. Okay, so on the exterior, usually with drawings, just look at the annotations or the legends and come to the actual drawings themselves, look at the specs, and that would kind of confirm the scope to you of what is actually included. Okay, so you know you've got a rain screen cladding system, you know you've got windows double glazed. You come back to your program, in the envelope bit, you know what the configuration for the envelope is. Okay, so you add the WBSs for those, right? So we've got rain screen, we've got aluminium, we've got glazing, we've got SFS framing. All right, so you add all of those, but the first that gets done is the METSEC, yeah, and then the SFS framing goes up. Okay, so we go here, SFS, F. What's happened here? What are we looking at? This needs to be closed. Okay, so we're back here again. Where is the framing? And this is where I was. So SFS framing, and then CP board. So at this point, you will have erected, before you get to the envelope, you would have erected your scaffolding. Okay, so prior to the envelope, you would have a WBS for scaffolding. It doesn't have to, you know, include too many activities. Just obviously put it scaffolding and a long duration. You don't want to overpopulate the program with unnecessary activities that you won't need to track. You've got to always refer back and think that each of the activities that you put into the program have got a budgeted labor unit. So when the program's calculating how much the overall budgeted labor units are, when it gives you a summary of, you know, what activities have been performed, how many labor units have obviously been achieved, obviously as planned and through execution as built. So it will calculate all of that. But the more activities you have in there, the more ambiguous the information that you're obviously processing is. Okay, so you leave it down to the activities that will actually be performed. For the scaffolding, you could just say it's a duration of when the roofing gets up, then you erect the scaffolding from ground floor all the way up to the 17th floor. Or because they're hanging windows, you can actually hang the windows from outside, but you will still need to from the inside, but you still need to come outside to make good and obviously fix on the EPDM. So these activities in this WS cannot start until the scaffolding's been erected. Okay, so the CP boarding, and then we hang the windows. Okay, so after the windows are hung, we know the building's more or less watertight. And then straight after that, we do the brickwork. And after brickwork, we do the rain screen cladding. Okay, the reason why you obviously do the brickwork straight before the windows, after the windows, as opposed to doing it before the windows, is that if you put the brickwork up and then you hang the windows, you'd have an ingress, right? Because you're supposed to make the building watertight. So the windows will come on first, and then you build the brick around the frame of the window. Okay, so there won't be any spaces for moisture, etc., to get through. Okay, remember, when you do the exterior of any buildings, you're supposed to make it watertight. So that's the reason why the brickwork obviously will come straight after the windows. So the configuration of the window hanging into the CP boards, etc., you won't have any ingress, you won't have any moisture. Literally, your building will be watertight and obviously insulated correctly, because you're trying to keep heat in as opposed to letting heat out. Okay, so this here would be rain screen cladding. Okay, and then that will be it. So with the internals, obviously you've got the roughings, internals, etc., the plant room, landscaping. What you would need to do is create, again, same as you did up here, block A, yeah, to block E. So what you do is just copy it, and then come straight back down to the internals, and then you paste that in there. Okay, alright, so they should come any minute. Yeah, it's taking forever. So as soon as that's done anyways, I'm assuming it's copied those activities, because I'm able to move it around. 1 second, so it's got envelope, yeah, so it's in there now. Okay, so you got the roughing, you just move that out of the way. That goes before the actual internals start, so it's the roughing and then the internals get done. Okay, so A to E, internal fit outs. Okay, where have we got that? Up there. Okay, so let's go back up, and then remove. Move that in. The idea here to always build your WBS first is because that will signify obviously the packages, the zones, you know, the blocks, etc. And then what happens is all of your previous training in terms of construction sequencing, in terms of phasing, the activities that happen in these initial phases all the way up to the fit out, you then obviously unfold and roll out those activities. With the envelope, you do the same thing as you've done here, which will be what? You just do one activity saying ground to, this is, we're trying to go high level, right? Because the computer's moving quite slow because we've got quite a few things that it's doing. Alright, so we'll just say this is from ground floor to 17th maybe. Block A, okay? So blocks A. Alright, so just to keep it high level, so you know you've got MetSec all blocks, ground floor to block A. So what we really should be doing is the envelope, we should get all of this and divide the, create other WBSs. So you'd have a WBS with all of these in it. For block A, for block B, for block C. So each one would have its own because they're all different elements on different blocks. So see each of those blocks as a particular project in itself, a mini project as part of a full project. Okay? Every single WBS for every element of work needs to be defined, and it needs to be populated with the tasks and activities as required by the scope to be delivered to the right configuration. Okay? So yes, it seems like a slow process, but it's what you have to do. Okay? You want to incorporate the full scope of works. What you're doing, obviously, by going through this method is making sure that you include in there all packages, look through the activities that you could, you know, put the activities down in, say, Excel, put the activities down on a piece of paper right through. And what you would usually do is, if you haven't got the sequence of work and you've got a PM, you'd sit with them and ask them what are the elements of work that are required, obviously, to be carried out. For this, obviously, it'd be easier because we've got the envelope. So you just make sure that they're high-level activities because you have got 17 floors for block A, B, C, etc. Okay, so as I said, this part of the envelope, you would have to create a WBS specifically that would have these as the sub WBS. So I'll just do that quickly just so you guys can see what it is. Alright, so they're all under envelope. You go to the envelope activity. You take your time. Just make sure, obviously, that you remember that incorporation of a full scope is always the order of the day. Okay? So, I will create another WBS and I will label this block A. Okay? And the reason for that is all of these elements are the same for all the blocks. It's just the envelope systems that all the various blocks have vary. So you can't use the same scope for them. So you look at each block individually, okay, off of the drawings, as we've been doing whilst we've been building the drawings. So as you can tell, with this block here, it's got a different system at the top, different system on the ground floor. When you scroll into it, it'll tell you obviously what the configuration is. And the reason why you have the aluminium on this side is because you have got a sea facing view, or sorry, a river or lagoon, etc., wherever it is that it backs off to, right? And the reason why you have anodized aluminium panels is because of the corrosion. Okay, water's obviously a highly corrosive component. Okay, and what you don't want is putting paneling on a building that eventually will rust and change the architecture of the building. And over time, you've got to remember that if the aluminium panels start to rust, inadvertently the substrate itself potentially could start to rust because you're bracing into the substrate. Okay, and the components that are bracing into the substrate, if they start to rust, it will transfer. Obviously, rust can actually peel concrete. Okay, so it will start to obviously break the integrity of the actual structure as well. So you're trying to prevent rust on that front. All right, so we've created that block A. We then move all of these into the component as sub WBSs for all of these. Yeah, so for block A, that is. So you move that in there. You do the same with this. You do the same with this. We'll rearrange it. It's just making sure that we get all of them under the block A. Alright, so you move that in as so. You move this out. It's the last activity. Alright, so all of these under block A, are they? Yes and no. Let's move this one more. Let's move this one more. Okay, so right, we've got SFS framing. Move the METSEC back up, because that occurs before SFS framing. CP boarding, windows, brickwork. Yep, that's it. So it's all done and it's all arranged. So you come back here, you see obviously that it's all arranged under the block A, and what you do is you populate the exact same scenario that you've just done. You do that same exercise again for all of the other blocks. Okay, so scroll down, you do the exact same thing. We've created the envelope for that. And all you could easily do is just copy that, come back here and paste it, and just give it a different name. Obviously, block A, block B, block C, etc. Okay, so that's how you obviously do the fast works to build these programs pretty quick, accurately. Make sure you incorporate the scope. Perform the task of creating all of your WBSs, looking at the scope off of the drawings. Have a good eye for detail when you look at drawings. Okay, as you can see, they're color coded. Drawings are not that difficult to read. Why? Because you always have, as you can see, the legends there. Tower crane will be located where? Right here, TCS. As you can see, the PGs are the tone passenger goods hoist to the side of the building. And as you can tell, if you noticed where the tower crane's been located, it's been located right next to what? The core. Okay, where the stairs go into. Now we've missed out the stairs because we need to put the stairs in though, right? And the stairs will go in as soon as the roof goes on. Okay, so you could tell the tower crane right next to this, and this is what gets built first, the core. Okay, if you look to this side as well, the same thing, the passengers hoist, goods hoists on this elevation here, the CTA common tower access. And what it does is, when this is being built up and you've built the frame up, the goods hoists will gain access through these hallways here. Okay, this hallway here, as you can tell. So they come up through here to the side of the building, right? And you come straight through in here and access all of these areas in the building. So if you were to create a site plan, you would take into consideration that all of the accesses for the goods hoist will be in areas, either the hallway or the bedrooms, because they're the least used areas during the construction process. Okay, because the bedrooms usually would have less M&E works to do. Okay, so that's the considerations. Okay, so you scroll down. If we wanted to look at a bit more detail in terms of the site logistics, you've got another tower crane here. Now the tower crane located here is to service the goods delivered, obviously, and I'm assuming the tower crane needs to be located in the area where the goods are offloaded and stored. So there will probably be a goods area within this location here. The tower crane, obviously, depending on the span, would be able to do what? Service this block here all the way. Okay, if you scroll down, we've got another tower crane there. So they've got tower cranes obviously to service all of the buildings. Tower crane 1, tower crane 2, I'm assuming that's tower crane 3. So this one here will service block C, and this one here will service block E. Okay, I'm assuming the span between this is between 55 and 65. The same with this will service block C and block D. whereas that one there will service block A, block B. Now you can see the passenger's goods hoist, and where does it locate? The openings come straight into the hallway. Okay, as I said, the hallway will be the access or the bedrooms. If you come and have a look, you notice it again. The access is through the hallway. Alright, you do the same thing. The access is through the hallway, as you can tell. So that's a goods hoist, and that's a passenger goods hoist. So passenger and goods hoist. Alright, and the same with this configuration here as well. Alright, so guys, we will stop the session there and continue it on Saturday, if that be fine. Sorry it was late. I hope it was informative, and I shall see you guys again on Saturday. Thank you very much for watching. Bye.